Yeah, so I had COVID if you're wondering why. So maybe you've already done this with Mahaney, I don't know, but like I want to go back to 2.8, the product rule. Let's see if there's anything there I can talk about or go through. 2.8. I taught that one Friday, and then the day I would have gone over it, I wasn't here. 2.8 was fine though. Fine. Okay, so the 2.9 was quotient rule, and I wanted to show you. I saw Mahaney taught it. I think she showed you divide f over g. Did she teach you as f prime times g? So she taught you as good. That's what I want. Okay. That's what I want. What? Or if you did like, so if you call it high and low, it would be low d high minus high d low over low squared. Or call like 1 and 2, like that's not a half, right? It's like 1 is like the top thing, 2 is the bottom thing. It's 2d1 minus 1d2 over 2 squared. All the same rule, just written different ways. So then there was some to practice there, just like regularly take the derivative. There were those tables. Find the tangent line. 1 on 2.9, can I help? 2.9's all good. So she was here to answer the questions.
It's 16.
Oh, no, I don't think she did. Then we like talk through 17. So they want the slope to be 1/9, and the derivative tells us the slope. So we're going to take the derivative of this guy using quotient rule. So the bottom times the derivative of the top would just be 1, right? Minus the top times the derivative of the bottom, which would just be 1 over the bottom squared. And then what do I want to set that equal to? The derivative tells me the slope. They're saying I want the slope to be 1/9. So I set that equal to 1/9. So on top, I'm going to set like 4 over x plus 4 squared equals 1/9. Cross multiply. I will get x plus 4 squared equals 36. But then be careful here, because if you try to solve this equation, there's 2 answers. So x plus 4 could equal 6, or x plus 4 could equal -6, because we're square rooting both sides. Square root 36, there's 2 of them. So if I solve this, I get x equals 2, and if I solve this, I get -10. And then if you plug those back in, you can verify, but you can see. Gauge, how's that? Make this fast and weird. Other ones. So, like, the good news on my end, because it's weird for me, because you guys kind of did 2 sections without me, like this one completely without me. But, like, we learn chain rule next, and then we start combining all the rules, so you will get definitely a lot more practice with them. Okay, so then 210, let's just talk through it. So the derivative of sine, do we remember that? Cosine. Remember, if it starts with a c, your derivative is negative, so the derivative of cos -6 negative sign? Did everybody watch the video? Can you go through like why the derivative of tangent is what it is? That's fine.
He told us not to write it down.
Okay. Alright, I'm gonna do, so there's four more here. I'm gonna derive them. I'm gonna show you like two of them, where they came from, how they get the answer that they get, and then I'll show you one, you'll do another, I'll show you one, you'll do another. Because you're gonna go through two. So I'm gonna say, let's say we have y equals tan of x. And you have to know the derivative of that. So most people just memorize it. But if you get stuck, sometimes it's nice to be like, crap, I can't remember it, but let me like go through the process of figuring it out. Now that we know quotient rule, we can do that. So tangent is sine of x over cosine of x, right? And then I can do quotient rule. This is like my high, and this is my, I always call it high and low. This is the Hades version of high and low. It's probably more appropriate. But high and low is fun to say. So my derivative would be the bottom thing times the derivative of the top thing. So what's the derivative of sine of x? Minus the top thing times the derivative of the bottom thing. So the derivative of cos is negative sine. And then over the bottom thing, squared. Which looks like a mess, but there's one trig rule that you have to know. Like you guys did a bunch of trig identities in pre-calc. The only one you have to know is that sine squared plus cosine squared equals 1. That's like a squared plus b squared equals c squared. It's just Pythagorean theorem, basically. And doesn't this say cosine squared 2 negative, so plus? Isn't that cosine squared plus sine squared on top? So I have 1 over cosine of x squared. Which I just want to make sure you understand that if I wrote it like this, it's the same. And then to avoid it being a fraction, they just reverse it, and the derivative is secant squared of x. So that guy is secant squared. And then I want you to go through a similar process and find out what cotan is. Even though you might already know it if you already looked it up. But go through and try to like derive it. So remember, cotan of x, you flip it over, so it's cosine over sine. Works out pretty similarly, but there is a little trick. Can I get you a blue one? The black one's over here. That one? So I should basically see what I'm teaching you that for the first time. Should I assume I'm teaching you that for the first time? I'll talk to the tennis. Yeah, I think the regionals are good. No, I think they split them up between Riverview and Brazil. That's the last thing I heard.
second in the state for tennis.
They sound like they'd be good. Run their wrench, so they're probably good tennis. That's usually how that works. Okay. So cotangent cosine over sine. So we're still going to do the same idea. So the bottom times the derivative of the top. Well, the derivative of the top is negative, so it's negative sine of x. Minus the top times the derivative of the bottom, so the derivative of sine is cos. Over the bottom squared. So this is the same as like sine 2x. I just think it's a lot easier to see when it's written in this form. Sometimes you guys get confused when it's like this. So you just gotta know they're the same. And then rewrite, like write it whatever way makes it easier for you. Then this one works a little differently. So that's negative sine squared of x. Negative times positive, and then this is negative cosine squared of x. Over sine squared of x is sine of x squared. Don't cancel. Canceling these would be wrong and not help us. But remember, you can't cancel unless it's in every single term. We have 3 terms and only 2 of them have a sine squared in it, so you can't just like straight up cancel it. But I could factor out a negative 1. And if I did that, on the inside I have sine squared plus cosine squared, which is 1, right? So that gives me 2 negative 1 over sine squared, and then to avoid that being a fraction, they just call it negative cosecant squared. So there's a lot going on there. There's like a trig rule, there's understanding that when you flip over cos, it's secant, flip over sine, it's cosecant, there's quotient rule. This one is negative cosecant squared of x. And again, it starts with a c, derivative thing. So that does carry. Question on 2. Or on that one, I guess. How many had them before I got to it? You had this the right derivative. Okay. I wanted to do the other 2 as well. So we're going to do secant. What is secant? What is it? What is it?
1 over cosine.
What was the other thing you said? Don't say it. So inverse cosine means like I'm giving you the value of the cosine. Like cosine is 0.5, tell me that that's not what we're doing. The opposite of cosine, like the reciprocal of cosine is secant. So let's do quotient rule with that. Bottom times the derivative of the top. What's the derivative of the top? 0. That's kind of nice. Minus the top. Bottom, so the derivative of cos is negative sine all over the bottom squared. So this is nice because cosine of x times 0 is just 0 and that goes away. And then what I have left is sine of x on top because 2 negatives make positive, and cosine squared x on the bottom. They wrote this so it's not a fraction also. They just kind of take this and manipulate it. Would you agree that I could write it like that? Cosine of x is times itself is squared, right? Would you agree that I could write it like that at the top? Just put like a times 1. And then what is sine over cosine? It's tan. And what is 1 over cosine? So again, like most of you guys are probably just going to memorize it, but it is nice to be like, if I get stuck, like I at least have some clue how it came, like where it came from, and I can maybe find it again. So this is tan c, or sec tan, or it doesn't matter. Just multiply. And then you guys try that with cosecant. Like you had that for your derivative?
Yeah.
That's not wrong. 2.9%.
The S&P 500 is down 0.29%.
I always pop up hot crabs. Like when I was just watching the stock market.
Does it like update real time? Like, it'll
so.
really? Like I want to see it move. I want to see it.
Oh,
It's 60 degrees and stuff.
Nice to know what you guys are paying attention to when
Yeah.
I'm doing that. What? Do you guys watch The Office? Like, they show that ball bouncing around. And then why is it right in the corner? What? Oh, really? Okay. Cosecant is 1 over sine. So that's my high and my low. My 1 and my 2, so it's the bottom thing. Times the derivative of the top thing, which is nice and that's 0. Minus the top thing. Times the derivative of the bottom thing. Cosine. Over the bottom thing squared. So you end up with that canceling, and you get negative cos over sine squared, but I'm going to write it as like sine of x times sine of x. At the top, I'm going to write it as negative cosine of x times 1. And then that is what? Negative. Good. Yeah. I say the whole word. Negative cotan, and then what's 1 over sine? So if the negative's like out in front, that's all one term. So you could put negative cosecant cotangent or negative cotangent cosecant. Doesn't matter. Again, it starts with a C, so your derivative's negative. Let's do those two, because that's 6 things we have to memorize. We've done 4 more, so let's just like put them all here so they've got them all in one spot. So if I said, what's the derivative of a to the x? Anybody remember that? No, you're trying to apply the power rule. When the power is a variable, that doesn't work. It's a to the x times the natural log of x. And then we had like that special case where if I say what's the derivative of e to the x, that's going to be e to the x times ln of e, but what's ln of e? They cancel, so you really just get e to the x. And then we also had derivative of log base a of x. Not big enough, people in the back. So then that derivative is 1 over x times the natural log of a. And then the 4th rule, which is really just a special case of that one, is if we have natural log of x, then the a is e. This a is e, so natural log of e just goes away and you just get 1 over x. But like that's 10 of them. There's 6 more coming soon. And you really have no choice but to memorize. AP doesn't give you a formula sheet or cheat sheet or anything. There won't be a formula sheet on your gateway. You really just have to memorize. That sucks. I'm sure there's tons of like, what's that flashcard site that's on Quizlet? There's tons of Quizlet on these, I'm sure. Make your own flashcards, but do what you gotta do to remember those. Alright, let's keep going. I'll do like 1, 2, and 3 here. Bless you. And then whatever else you guys want me to. So sine of x, tan of x. So you're going to start to have to combine things. So there's trig rules, and this is product rule, and then next week we're going to do the chain rule. So, this is product rule. That's like my first thing. My second thing. So, product rule says second thing times the derivative of the first thing. So, the second thing is tan times the derivative of the first thing. So, the derivative of sine is just cos. Plus, so the product rule is plus, quotient rule is subtract. Plus 1d2, so then I'm writing down sine times the derivative of tangent, which is secant squared of x. So I'm not sure yet if this is gonna I think it's gonna cancel, but I'm gonna try. If it's on a free response, you're good. But if it is on a multiple choice, they're gonna probably reduce it. So let's see what happens. So tan is sine over cos. I'm multiplying it by cos, so right away that part is just sine. Plus, and then over here I have sine, and secant is 1 over cosine. So I can see them writing their answer like this. So see if you can follow where I'm getting this from. Again, you wouldn't be responsible for doing that, but you might have to match up. So tan I broke down to the sine over cos. When I multiply that by cos, those go away. When I flipped over secant, this becomes like sine over cosine squared. So sine over cos is tan. And then you have 1 over cos left over, so that shouldn't be squared actually. That should just be tan. How's that for 1? Second one, find the derivative of pi over 6 if we know someone got to use quotient rule. So it's the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is tan x sec x, over the bottom squared. We have 3 terms, right? That's a term, that's a term, and that's a term. Is there anything you can cancel out of all 3? Cancel out a secant. Make my job easier. So now it's just 1 minus x times tan of x over sec of x. And then our job is to plug in pi over 6. Pi over 6, how many degrees? What's pi? Pi is 180. Pi over 6 is 0. Right? So that's 30 degrees. So at that spot, we are 1, 2, 3 tick marks to the right, and 1 tick mark up. So your x value is the square root of 3 over 2. Y value is 1/2. So I'm trying to find tan of 5 over 6, first of all. So tan is y over x, right? So it's 1/2 over the square root of 3 over 2. But we don't divide fractions. We flip over the bottom one and we multiply. So it's 1/2 times 2 over root 3. And those cancel, so you get 1 over root 3. Find sec of pi over 6. So sec is what thing flipped over? Sec is cosine flipped over. Cosine is the x value. Our x value at that spot is the square root of 3 over 2. So we gotta flip that over. Make it 2 over the square root of 3. And that's a legitimate answer right there. It looks disgusting, but you can stop. How's that one? And then 3 is just type it into your calculator, so you'll do the, I think it just is it d or dx? And there is a cosecant button in the catalog. Cosecant isn't on like the main, it's not in here anywhere. So I'm gonna go F3, differentiate, but I want cosecant. I'm saying secant. So if you go second catalog, which is, no, you don't even need second. Catalog just a button. Like 3 buttons above the 8. It says catalog. And then if you scroll through, you can find secant. Or if you hit alpha S, it'll jump to the S's and you can find it a little faster. There's secant. Why am I doing secant? Round number 3. What am I supposed to be looking for? Cosecant. That's going to take forever. So I'm going to hit alpha and then C. That didn't work. How do I shortcut it?
You have to do it twice on mine.
What do you mean?
You just like do alpha S and then alpha S.
That's weird.
Yeah.
There's cosecant of 4x. But we have to square that whole thing. So then we're going to say comma x. And then, I don't really even care about that. And then I'm going to plug in x equals 2. So remember we hit the vertical bar. And then x equals 2. And it'll plug you in. And get you that. If I want a decimal, what do? Diamond enter will take that and turn it into a decimal. So I go through any of that again? What'd you say? Oh my god. Didn't see nothing. Okay, real quick, let's look at 15 and 16 on here. Again, I don't want to spend like a million hours on something that is not on the test very often. But this question is saying y equals tan of x. Find y prime when x equals what? 5/3. So the derivative of tan is secant squared. And then you'll plug in 5/3 and figure out whatever that is. I'm just trying to help you get from like this step. So the next one, what's the original equation that they're giving you there? Just in a jerk face way. Secant of x, and then I'm supposed to plug in 5/6. That's what's right there. So you're just going to take the derivative of secant, which we know how to do without that stuff. So secant x tan x, and then put the 5/6 in place of the x. some of you have done most or all of this section, some of you have started, so everyone's kind of out of it. Is there anything else on 210 I can go through? Yeah. Do you have the tangent line? Can you tell me what the tangent line is? That's it? There's no like, so it's not why the tangent line's there, the normal line's there? Okay. If the, so there's two issues going on here. I just want to make sure we get them both. So let's say that the tangent line was this. I know it's not in this one, but if this is the tangent, and I said find the normal, what would you put in the blank? -1. So that's just like understanding. So that's not the question. The question here is, okay, my tangent line is y equals -1. Well, what kind of line is y equals -1? Don't say straight. Every line is straight. Don't say vertical either, because it's horizontal. That's y equals horizontal. So y equals horizontal. So what is normal or perpendicular to a horizontal line? It's a vertical line. And what's the equation of any vertical line? X equals something, and what's the only x value we have? Is the pi. Fair enough. So you didn't get stuck because the typical normal thing. You got stuck because the horizontal vertical. Okay, that's cool. Yes. Concepts of plan. Other ones. So if we were doing like a normal unit test, we would have one like we'd be done with the unit. So we would do unit review. Tomorrow I'd probably do a practice test, test coming up. But we're not. This stuff is still all relevant and could be on the gateway. We're just going to do a little more before we get to the gateway. So I would like you to do this, and tomorrow we'll go over any questions you have, because these are still very good questions for the review. We're just not stopping to take a test until you have until 36. So, but Unit 2 and Unit 3 are combined into one test, basically. So do this to review, but understand there's not a test like tomorrow, but there is one coming down the line. Other questions for me on 2.8, 2.9, 2.10, the review yet? What number? Where are we at? Well, this 3 right here, that's a variable. So you can think of it like sine of x over x. And then the derivative of the x on the bottom is 1. So then is that what you're saying? Fair enough. Anything else for me? So like by tomorrow, I would expect you to be all the way done through 210 and the review. And we'll do section 3.1 tomorrow. We'll start the chain rule tomorrow. Chain rule's fun. And then you do a double chain rule, which is like 2 chains. So I'll bring him in as like a guest speaker on that day. What if 2 chains walked in the company? Did I give you one?